So we are doing some stuff today about circles, actually graphing circles in the coordinate plane. This is, I used to teach this in Algebra 2. So these are called conic sections. And if you guys can imagine a big cone, like a construction cone, let's say, okay? And conic sections are if you have that cone, and there's different ways you can slice through the cone. And so if you have a cone, just imagine that here in front of me, if I were to slice it parallel to the base, and then look at the top of it, what shape would you see? A circle, all right? So that's what's called a conic section. So what we're graphing today are circles. There's other conic sections too, depending, again, on how you slice the cone, all right? And so if you slice the cone on a slant, and then you take the top off, what do you think that shape that you'd look at would look like? Kind of an oval shape. Yeah, that's called an ellipse, all right? And an ellipse is the path that the Earth takes around the sun, all right? So those are ellipse shapes. So there's a whole bunch of conic sections that circles, ellipses, hyperbolas, and parabolas are all different conic sections. And so we are just looking at these circles of conic sections. And it turns out today's going to be super easy. And so the standard form of an equation of a circle in a coordinate plane is x minus h quantity squared plus y minus k quantity squared equals radius squared. All right, looks really complicated, but this is the standard form. You'll notice we have x with something being squared, x squared plus y squared equals radius squared. Doesn't that kind of look like another formula we know? Like a squared plus b squared equals c squared? Pretty kind of similar there. It does come exactly from the Pythagorean theorem, okay? And what we get is it traces out a circle of a particular radius. So it turns out that h comma k is the center of the circle, and r is the radius. Okay. You'll notice in the formula there is a subtraction sign within that formula. You'll notice that our vertex is the opposite. All right. That is what looks to be a negative h there, but it's positive h for the center. Okay. So when we want to graph some of these, just a little bit of practice here. So on number 1 here, here's our standard form. I like to really call it H and K form. HK always gives us important parts of any graph that we're working at. So what is the center going to be? Is it for -2 or is it -4 +2? What do you notice? The signs kind of change. Because the formula has a negative in it, what we want is always the opposite, okay? So it's sort of the opposite of what we're looking at. How do we get the radius? So 25 is r squared. Square root it, yeah. So we want to square root that, and so we get a radius equal to 5. So that's important to remember that what we're equal to is the radius squared. So how do we graph this? Super easy. We're going to start at the center, so we're going to plot -4, 1, 2, 3, to the left 4, and then up 2. So here is our center. And then from that center, we're going to just count the radius. The radius is 5. So I'm just going to do a sort of northeast, southwest of 5 units. I'm going to go north, 1, 2, 3, 4, 5. That's my radius. I'm going to go east, 1, 2, 3, 4, 5. I'm going to go south, 1, 2, 3, 4, 5 from my center, and 1, 2, 3, 4, 5. So all you have to do is count 5 units, above, below, left to the right. Okay, and then it's a circle. So connect the dots in the circle as best you can. Okay, let's look at number 2. What's missing? The K is missing, yeah? So x minus 7 quantity squared plus, can I rewrite it with a K? 0, yes. So y minus 0 quantity squared equals 4. So something is missing, we can fill it in. So what is our center going to be? Positive 7, 0. And then again, the radius squared equals 4. So what is our radius? 2. The radius would be 2. All right. So once again, I'm starting with my center point is at 7, 0, 1, 2, 3, 4, 5, 6, 7 to the right, up none. So there's my center. And then my radius is 2. So I'm just going to count 2 units up, right, down, and left of center. And then you can plot your circle. Easy or hard? Pretty good. Let's look at number 3. Number 3. And if you're done with number 3, you can do 4 as well. But number 3, what is the center? Positive 3, negative 1. They switch. Positive 3, negative 1. And remember, r squared is 49. So what's r? 7. Square root of 49 is 7. All right, so we're going to plot the center at 1, 2, 3, negative 1, and then just count your radius. 7 away. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6, 7. And then connect the dots in as close to a circle as you can get. Looks kind of more like a rounded square usually. But that's okay because it's super easy on Delta Map. Super easy. Because they have the circle shape, you just have to drag it out where you want it to go. So it's really cool. All right, questions on that? Now, let me ask you a question. If you had a picture of the circle and you knew that this center was at 3, negative 1, and you knew that the radius was 7, could you then go backwards and put it into standard form, put it into the equation? Yeah, it's not too hard, right? We would x minus the 3 and square it, and then the y plus the 1 and square it, and then we have 7 squared. So we want to be able to go backwards as well. So if given a picture, can you write the equation? Sure, not too hard. Identify your center, identify your h and k, and plug it in, all right? So, any questions on that? So easy, yeah? Okay, turn the page. All right, number 5, what's the center? 5, 1. Positive 5, positive 1. What's the radius? 8. R squared equals 64. The radius is the square root, which is 8. Very easy to just identify those. Number 7, what's the center? 0, 0, negative 10. Hey, they're asking for a diameter. I don't know that, but what's the radius? 6.5. How'd you get that? All right, you took the square root of 42.25, so we get, you said 6.25? All right, and then what's the diameter then? 6.5, sorry, thanks. I didn't have it in front of me. 6.5. So what's the diameter? 13. How'd you get the diameter of 13? Times by 2. Good. All right, and then number 9. What's the center? -2, -9. What's the radius? Good. The square root of 196 is 14, so we have a radius of 14, but they're asking for circumference. What's the formula for circumference? 2 times pi times radius. Very good. So we're going to get 2 times pi times 14. I think I'm just going to write 28 pi because that's easy, and I don't need my calculator. Okay, so little formula from before. Last one, number 11. What's the center? 3, -4. Good. What's your radius? 9. Good. Square root of 81 is 9. But it wants area. What's the formula for area of a circle? Pi times radius squared. Excelente. So our area is going to be pi times 9 squared. Oh, which is just 81 pi. Hey, that's kind of handy. Okay. Do you guys have questions for me? That's it. Delta Mass open. How long was that? 11 minutes, almost 12. Oh, it was close.